Hello everyone, my name is Eric Sirwa and I'm here to walk you through my performance assessment for WGU D493 Advanced Scripting and Programming Applications. So for this assessment, this project, what we were asked to do was essentially pick a date and a location, plug that information in, make API calls to fetch some weather data, take that weather data, store it into a class instance, do some fun stuff with that, and then store the data from that class instance into a database, query the database to get that information back. All right, so now that we got the introduction out of the way, let's go ahead and hop right into the work. The location I chose near and dear to me. It's Montreal, where I was born and raised, first 20 years of my life. And I chose June 24th. The reason I chose that was because that's Saint Jean-Baptiste Day in Quebec. It's like a Pioneer Day in Utah. It's just a fun day. I figured why not? You know, if we're going to look back, let's see what it looks like on a day that everyone wants to go out, have fireworks, barbecues, all that kind of fun stuff. So let's go ahead and get started here. C1, it asks us to create a Python project in the IDE doing the following. Create a class with the following class instance variables for your chosen location and date. So here I have the weather data class. And then I'm going to initialize it with the latitude, longitude, the day number, the month number, and the start year. The start year is essentially the date we're going to start. We're going to look back 5 years. So I'm going to start in 2025, and then I'm going to look back 5 years from 2025. That's just what I'm using to initialize. All right, so I got everything here all set up. Something to note is the years, the temperature, wind speed, and precipitation. Those are all the instance variables or attributes that I'm storing them as lists. And the reason I'm storing them as lists is because the rest of the data that we're going to get is either going to be constant or it's going to be an aggregate value, an average or sum or min max, right? And I don't want to have, 2025 with the temperature, 20 degrees, 30 degrees, whatever, and then the aggregation value, because then that same aggregation value is going to repeat on every single row, and I just didn't want to see that. So what I opted to do for this project was to store them as a list, and then I'll just have one row with the list of the years that's going to be looked at, the list of the temperatures that's provided, wind speed and precipitation, and then the average overall. So that's how I'm doing them. I'm also going to set the aggregate values to none to get started with. And then you'll see here, I have the start year. So when if I plug in 2025, it's going to start at 2025 and look 5 years back. If I put 2020, it'll do the same, look 5 years back. And then the number of years, because that's as indicated in the project, it's going back 5 years. All right. Bullet 2 is asking us to write a method for each of the following daily weather variables using the Weather API web link to pull data for your chosen location and date for the most recent 5 years. So the mean temperature, the maximum wind speed, and the precipitation sum in inches. This was an interesting one. I decided to break it up and have a little bit of fun with it. So here we go. So bullet 1, make the API call. So here I have a doc string that kind of, if you want to go over it, hover over or use the help, it'll kind of outline exactly what the method is, a little description, and then what it returns. Here is the current year. I'm in a for loop. I'm going to loop back, so from the start year, and then I'm going to go one back 5 times. And then the weather URL that I put together using the variables that's provided in the init. Then the response is going to be what the request method gets. And then if I get a 200, so essentially a success, I'm going to print the response code with a little message and then what year I was successful in retrieving the data for. Then the data is going to equal response.data, JSON, and then I'm going to throw that information into a dictionary, and then that information is going to go into this empty annual weather list. So I'm just appending it. So it's going to be a list of 5 dictionaries, and then later I'm going to go through that dictionary or that list and pull out the elements I want from the dictionary, and we'll see that soon. And then if it fails, I have little catches here to try and like the accept messages, and to print what the error message was to help with debugging should I need to. Then I'm going to skip over this. I'm going to come right back to it. But these next three here, C2 bullet 2, C3 2 bullet 3, and C2 bullet 4, are essentially the same call. Ideally, I would have made them as one method, but the requirements kind of outlined that they wanted a separate method for temperature, a separate method for precipitation and wind. So I broke them out, but ideally I would have combined them into one method. But what I'm doing here is I am, again, the doc strings, I'm passing in a weather item and then the type of aggregation I want to do. So the weather item is going to be temperature, wind speed, or precipitation, and the aggregation is going to be if I want to get the average, the sum, the min, or the max. And so here we go. For this one here, I'm passing it in. It's going to show I'm passing in the average, and it's going to let me know, print a little message. Hey, we're getting the average temperature. And I'm just going to do the sum of the weather list divided by the length of the weather list. Obviously, get the average. It'll do the same for the max weather and the same for the min weather. And then if I'm passing in a wrong item, then I'm going to get a message that says invalid aggregate parameter. And then if it fails for some reason, then I'm going to get an exception. This one, it's the same thing. I'm just doing it for wind, so I call it get wind. And then here you go, get precipitation. I'm doing it the same for precipitation. The only difference with precipitation is I'm doing the sum. So with the average, I'm taking the sum and I'm dividing it by the length. This one, I just removed that second part and I'm only getting the sum because we want the total precipitation over the 5 years. And so I also have up here a weather list. So what this does is I get an empty weather list. I create an empty weather list, and then I do I look at the dictionary, right? And we have in the annual weather list, it's a list of 5 dictionaries. And essentially what I'm doing is I'm going through the dictionary and pulling out the items. So I'm pulling out precipitation from each dictionary in the list, right? And then I'm putting it in a list. So it's going to be a list of just the 5 temperatures or the 5 wind speeds or the 5 years. And so that's what I'm passing into these, right? This weather list. All right. C3 is create a main.py file type, and within the file, create an instance of the class in part C1 to call the methods used in part C2. So let's go back to the main. I created the main here, and I am right here at the top, daily info equals weather data, and I'm passing in what I need to initialize this instance of the class. Easy peasy. C4, write a second class that creates a table in SQLite using the SQL Alchemy ORM, Object Relational Mapping module. Include a field for each of the following instance variables in the table. So here we go. A second class that creates a table in SQLite. So here we go. I have this file. It's called weather_db.py. And I'm importing the following things that I need for this file. I'm creating the base right here. And then C4, I'm creating the class for the table. So the table name, I'm going to call it the weather table. Keeping it simple here. The ID, I'd like to have an ID, primary key column. And then here's the following variables, or whatever I need in the table, right? And then this class here is the database itself. So that's going to go into C5. Populate the table created in C4 with the weather data for your chosen location and date. So it's kind of a combination of these. So class weather DB. I'm going to create the engine. I'm going to do what I need to do to kind of set it all up, create the session. And then I'm going to have a method in this class called add weather. And what this does is it's just going to add the weather data from the weather data class into the table. So I put everything together that I need to put together. Then I'm going to add the weather, and then I'm going to commit. And then if that's successful, I'll print successfully added weather. If not, we'll hit the accept if something goes wrong, and it'll print it failed to add, and then it'll give us the error message. And then finally, I'm going to go ahead and close the session. Very important. Make sure you always close the session when you're done. And finally, C6. Write a method that queries the table you created in SQLite and retrieves the data you stored in part C5. All right, so query all. This one's short and sweet. All this is it's going to go ahead. I'm going to open the session, and then I'm going to query. And then since we want everything, we don't need to filter or anything. We're just going to be query all. And then it's going to return a weather query. If we fail, again, it's going to print a little notification, fail to query, and then it's going to give us the error message. And then finally, again, very important, close the session. All right, so that's going to take us here back to the main. So I'll quickly go through it. I go ahead, I create the instance of the weather data. Here, the DB URL is the database URL that we're using for SQLite and SQL Alchemy. And then DB is the instance of the weather DB passing in the DB URL. So now I'm going to get things set up. This is just going to print the list of dictionaries, more just for debugging, so I could see, okay, yeah, everything looks good. Not needed, just more for my peace of mind. And then I'm going to go ahead and I'm going to set the daily info. So I'm going to go ahead and put in the list, right? The list of years as the year, the list of temperatures and the temperature instance variables in the class. And then here I'm going to call the average, max and min temperature, or I'm going to set them using the methods I created. So I'm calling the get temp, I'm passing in the temperature, and I'm going to go ahead and set the average, max, min. I'm going to do the same, except for precipitation, it's the sum, remember that. From there, I'm going to go ahead, I'm going to add the information from the weather class instance into the database. I'm going to db.addWeather daily info. So that's just adding it in. And then to verify that it's been added in properly, I'm going to query it and store the result that's returned in this all weather variable. And then if there's something in all weather, then what I want to do is I want to present it nicely, right? I want to make it look nice. So I'm using the tabulate module. And so what I'm doing here is I'm setting up my table headers. Because it's a fat table, it's really wide, I have a whole bunch of column headers here. And then, then what I'm doing here is for record in all weather, I am going to put in the information. Very important, make sure that it lines up. So the first one's ID, the first one here should be ID. Here's latitude, and so on. Make sure they line up and they're in the right order. And then I'm appending that to the table data, which is an empty list I have here. So now it's going to get populated. And then I am going to print the tabulated version of it in the fancy grid format. If it fails or it doesn't work, I'm going to have this message, no weather data to be found in the database. All this is stored in the main method. And so to run it, I have here if __name _ equals main, then run main. So let's go ahead and run it all, make sure it all works. So you see here, it's all empty in the terminal. Let's click play. Here's my successful status codes, very nice. Messages, I'm not seeing any errors. And finally, here's the table. So it looks like it all populated very, very nicely. As you see here, here's the list of years. I turned it into a string so it can go inside. Same with the temperatures. Very nice. Then here we could see the average information, the max, the min, all the different aggregates on one line. Again, on one line, so it doesn't repeat itself over and over. We don't want 72.6 to be repeated over and over and over because it's an average over 5 years. It's not going to change. It's going to be the same for the same 5 years. And there you have it, a nicely formatted table that gets printed out. I also have a test.py file, which I have to run tests. And so the 3 tests that I have is, first I'm going to go ahead, I'm going to set up the class. And then I have test 1, and that's just checking to make sure the annual weather instant attributes have been populated. Test 2 is making sure that I'm populating everything properly. And then I'm going to make sure the attributes, the lists have 5 items. They're supposed to have 5. There's 5 years. So I want to make sure that they actually have 5 in that list. So make sure it's a length of 5. And then test 3 is, I'm just keeping it simple. I'm checking if the average temperature instance attribute has changed from none, because it's initialized with none, to an actual number. And so there's 2 ways that you can run it. I'm just going to click play up here, make sure it runs, setting up, it's doing the tests. Ran 3 tests. Okay. As you can see here, test 3 passed, test 2 passed, and then test 1 passed. So everything passed, everything looks good, no issues. Yeah, that's my project. Thanks for watching.